Well, let's try this again. Third time's a charm, they say. Welcome back to Ecocentric Homestead. Today I have a tutorial for you. Our tutorial is about keeping track of weather data. We want to keep track of weather data at your particular planting area. I don't usually say you want to, but in this case you want to. The reason being, a microclimate can be very micro indeed. I can have up to 10 degrees difference some days at my property as opposed to the bottom of Kite Cove, which is only like 2 miles away, depending on the direction of the wind. And you can also experiment with different wind breaks and such to adjust your microclimates. Now, if you want to pay the money out, you could buy something like this, but honestly I don't trust them. It'll give you your wind speed and direction, which is good, but the part I don't trust is the temperature readings. I think that these would probably be still affected by direct sunshine. I don't know, I haven't tried them. So, rather than do it that way, I suggest putting a max-min thermometer in a Stevenson screen. So this is an example here. The air flows in through the bottom and out through the sides and out through this gap on the top. And when you open it up, you just have a drop down. Now these two thermometers in here, I think you can still buy them. I don't know where, but I think they are still available. These are just mechanical thermometers that you reset every day, and they will keep, when it goes down to the minimum, one marker will drag down to the minimum, and then your second marker will drag up to the maximum. In the local stores around here, for the most part, I can get these things. And what I found out by the hard way, I went and I thought these should run on different frequencies. So I bought 2 of them. But I found the sensor only runs, all the sensors for this type runs on the same frequency. So for its radius range, you can only have 1 sensor. And if you have 2 receivers in range of this 1 sensor, and one of your receivers is in range of a second sensor, it will still record from the sensor that was started first. So I have that one, and another company makes a similar one. So this is Lacrosse, and this is Accurate. So because it's another company now, this runs on a different frequency. I also have a third one that is run to the small cold frame. That one is wired, so you have a little receiver about this size, and there's a wire coming out from it, fairly long wire, with a sensor on the end, so I can run it out through the window and run it down into my small cold frame. The sensor for this one I currently have in the large cold frame, but I'm going to put it in the shady plot so that I can record temperatures. This one's in the sunny plot, and this one is in the, I'll have this one in the shady plot, and I'll be able to record temperatures even in the winter when there's piles of snow. These, on the other hand, I'm going to have to make one of those Stevenson screens and hang this inside. This is a max-min thermometer from AccuTemp. I have to remove the battery every time and put it back to reset it, but that's not a problem. I'll have to take my notepad out and reset them. I have 3 of them. So there's a white one, black one, I have another black one. And so that should do my recording. I'm recording a lot of places because I am doing a lot of experimenting, which I've talked about in earlier videos. You might only need 1. I'm suggesting that you'll probably need at least 2 because you're going to want to have your basic temperature out in the field in the sunny area. But if you have any sun traps or shady areas, you're going to want to record that as well. Rain gauges, they're fairly simple. You really just need a straight lighted cylinder with the graduated marks on the side. You can, however, use recycling, and you can make one out of a pop bottle. What you do here is, as you can see, the top of the pop bottle has been cut off and turned inside, and then you have a colored liquid, something like water with food coloring, in the bottom that comes to the 0 mark. That way, when it rains, it'll be somewhat diluted, but not much, and then you can get an exact measurement as that liquid is added to from the rain. The wind speed and direction, that is important because in the winter, your trees and higher shrubs, they're going to be affected by wind chill. And both in winter and summer, all your perennials are going to be affected by the drying effects of high winds. The direction, because my windbreaks, like here, I have a windbreak to the east, I have a windbreak to the north, one to the northwest, and some buildings to the south and southwest. So the only wind that gets the main area of my garden is southeast and straight west. And so I can, if I add a wind monitor that told me both the wind speed and the wind direction, I can analyze that for wind chills and the drying effects of different directions and speeds of wind. I don't have one yet. Hopefully I can either find out how to make one, or I can come up with the money to get one. Now, let's start the computer side of it. How we are going to go about keeping track of this as our data entry and using the computer to calculate all of our wind chills, our daily GDU, and the accumulated GDUs. I'm using a spreadsheet program, Microsoft Excel, which most people know about, but the formulas that I will be using are fairly basic, so I think most spreadsheet programs will recognize them. So when you open Microsoft Excel, this is the page that will come up first. First thing I'm going to do is go down on the bottom here, and where it says Sheet 1, I'm going to right click and I'm going to rename it. I'm going to name it where I am recording my temperature and wind data at. So this one will be Sunny Plot, which, as I already said, will be the basic temperature. What it is at the sunny plot, that's what the temperature is outside here. I'm going to go over and show you one that I've already done here. This is a workbook that I'm building, but on the bottom you can see I've got sunny plot, I've got one for shady plot, sun trap, east cold frame, west cold frame, my sunroom, and my bay window. So we'll go back over here, and in the first row we're going to put our headings. So we're at A1, we put in date, tab, then max temp. I'm doing degrees Celsius. Min temp in degrees Celsius. Average temp in degrees Celsius. And then is our precipitation in millimeters. Our total precipitation. Once again in millimeters. Then we have our wind speed, which we will record just average wind speed. In Canada it will be kilometers per hour. You can do it meters per second if you want. Or in the United States it will be miles per hour. Direction and wind chill. And then I'm going to skip a space and I'm going to put in DGDU for daily GDUs. Base 5, this is your cool season plants, that's base 5 Celsius, base 41 Fahrenheit. AGDU for accumulated GDUs for base 5. DGDU for a base 10. And AGDU for a base 10. Now I'm going to widen out all of these columns so that you can see all of the editing. And then for the date, I don't recall working with other spreadsheet programs. I think Microsoft Excel is the only one I've ever worked with. When you put in the date in this A2, you put in a date that the Excel will recognize. I found out it doesn't recognize JAN-day-year. It does recognize the day JAN-2018. Now I'm using 2018 because I'm going to use 2018 data for this tutorial. Now as you can see, it automatically shifted it over to right justify as opposed to the standard left justify. That signifies that it did actually recognize it as a date. So we'll go back to A2, and this little square in the bottom right corner of that cell now, we'll click and hold on that and we can drag that down, and you can see it goes January 1st, January 2nd, 3rd, 4th, 5th, and so on. There's 365 days in a year, and we started out with on row 2, so we'll go down to row 366. And on row 366 we have December 18th. Now you notice our headings, we can't see them anymore. So let's scroll way back up to the top again. You just highlight A1 there. We'll click on View and go to where it says Freeze Panes. Click that. It says Freeze Panes, Freeze Top Row. We'll click on Freeze Top Row. Now you see a line underscore the top row. Now if I scroll down, the top row remains. So no matter where I am in the year, I can see what each column is telling me. The next step now, our max temp is something that we'll be recording directly. Minimum temperature we will record directly. Precipitation, wind speed, and wind direction. The rest are formulas. So I am going to, for the purposes of this tutorial, put in some fake data here in the first few cells, and then I'll show you the formulas that go in there. Okay, so I've just filled in some data here, sample data, and we'll go now to average temperature. When you put in a formula in Microsoft Excel, you start it with an equals, and your basic average formula. After the equals, I need to put in an opening bracket, and then if I click on B2, it will automatically put B2 in my formula, plus click on C2, that's our min temperature, closing bracket, / for division, and 2. Now if I press enter, it calculates that at 24.75. The maximum temperature was 32.2, minimum temperature is 17.3, the average of 24.75. And once again, if I hold down the mouse button on that little black square and drag it down, it will change the data. Look at the B and C, B2, B3, B4, B5, and so on. So it's calculating from the row that it's on. For our precipitation, total precipitation, we're going to put in equals. For the first day, we'll just click on the precipitation for that day and press enter. The reason being, the cell up in F1, that's a text cell, and you can't add a text cell and a number cell. However, on January the 2nd, we can do equals the previous day's accumulation plus today's accumulation, press enter. Now if I drag that down, now we can see the precipitation is accumulating. For the wind chill, I haven't figured out the formula for that yet, how to put it in here, so for now I am going to have to go with the wind chill charts. GDU 5. Now to calculate GDUs, as we said in the previous videos, it's your average temperature minus your base temperature if that average temperature is greater than the base temperature. So for that we need a formula, an if formula. If average temperature is greater than 5, comma, space, then we do average temperature minus 5. Otherwise, it's 0. No heat accumulation. We can take that one and drag them down, and it calculates them all for us from each row. accumulated GDU is the same as the precipitation, equals K2, enter, and then in the next one we'll do equals L2 plus K3, enter. And we do the same thing with dGDU 10 equals, if our average temperature is greater than 10, then we can do our average temperature minus 10. Otherwise it's got to be 0. And you drag it down. In AGDU, equals M2, and then equals N2 plus M3. And this is how the file will work. It starts over at each day. You've put in your maximum and minimum. It calculated the average. And then over here, from the average that it already calculated, it calculates the dGDU. And each day, it adds up an accumulated heat in the AGDU column. Same thing with your precipitation. You enter the precipitation, the computer will do the accumulation for you. And that's where I have to end that, because this video is getting longer. Tomorrow I will give 2 Canadian examples. One from close to me in Gander, and one from out on the prairies with an equal amount of heat accumulation over the growing period. That may be in 2 days' time, because my internet, it's awful slow loading. It takes me a full day to load a video. So I hope you found that helpful and interesting. Click that like button, leave me a comment, and I'll see you in the next video.